Hey viewers, from this video you are going to learn the range of data types. The range of data types is such topic which is normally ignored or not covered in detail, but in this video we are going to cover in detail. So let's start the video. If you have missed the video on the data types, the link is in the description. Please watch it before continuing with this video. Before starting with the data types, let's understand how binary numbers are stored in memory. We already know 1 byte is equal to 8 bits. If we have only 1 bit in a memory, what are the numbers we can store? We can either store 0 or 1. If we have 2 bits, we have 4 possibilities: 0 0, 0 1, 1 0 or 1 1. Let's try to get a relation on how to find the minimum and maximum numbers we can store in a memory. In these both cases, we have the minimum number can be stored is 0, and in the first case the maximum number we can store is 1, which can be written as 2 to the power 1 minus 1, and in the second case the maximum number we can store is 3, which can be written as 2 to the power 2 minus 1. So we can write a relation as the minimum number is always 0 and the maximum number is 2 to the power n minus 1, where n is the number of bits we have. We got our formula. Let's check whether it works for 3 bits or not. When we have 3 bits of memory, we have 8 possible combinations: 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. Here also the least number is 0 and the maximum number we can store is 7, which can be written as 2 to the power 3 minus 1. So we can come to a conclusion that the relation we deduced is correct. But you might get a doubt: what if we want to store a negative number? Don't worry about it. It will be covered in this video in the later section. The first primitive data type is integer, which occupies 4 bytes in the memory. 1 byte is equal to 8 bits. We have 4 into 8, which is equal to 32 bits. We need to find the range. Range is the minimum and the maximum number which we can store in a memory. The minimum is always 0 and the maximum can be calculated by the formula we deduced, 2 power n minus 1. Here n is equal to the number of bits and we have 32 bits in the integer. So we have the maximum number can be stored is 2 to the power 32 minus 1. But this is just for the unsigned integer, which means we have only deduced a formula to find range for the positive integers only. But what if we want to store a negative integer? For this purpose, we can use the first bit, which is also called as the most significant bit, to declare the sign of the number. If the number starts with 0, then it means it is a positive number. But if it starts from 1, then the number is negative. Since 1 byte is occupied for the symbol, we are left with 31 bits. So the range can be minus 2 to the power 31 to plus 2 to the power 31 minus 1. You might be thinking, if we have plus 2 to the power 31 minus 1 in positive, then why don't we have a minus 2 to the power 31 plus 1 in the negative side? The answer is very simple. When we are writing numbers from negative to positive, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, we can see all the numbers have a negative pair, but for 0 we don't have any pair. Plus 0 and a minus 0 are both same. So when we are writing the range for the signed integer, we neglect minus 0 and add a number to the negative side. So we finally have minus 2 to the power 31 to plus 2 to the power 31 minus 1. I hope you understood till this part of the video. The second primitive data type is float, which occupies 4 bytes in the memory, which means we have 32 bits of memory. If we apply the same formula as before, for a signed float, we can get the range as minus 2 to the power 31 to plus 2 to the power 31 minus 1. There is no unsigned float in the programming language because the hardware of the computer is not designed to take an unsigned float as an input. Float can only store up to 7 decimal values. But what if we want to store a value which has more than 7 decimal values? Then we can use double. Double is a data type which can store up to 15 decimal points. Double occupies 8 bytes of memory, which means we have 64 bits to write a number. Just as in the case of the float, here also we cannot write double as unsigned. By formula, let's only find the range of the double, which we can write as minus 2 to the power 63, 2 plus 2 to the power 63 minus 1. The third primitive data type is character, which occupies 1 byte in the memory, which means we have 8 bits to write any number. The range for an unsigned character is 0 to 2 to the power 8 minus 1, and for a signed character we have minus 2 to the power 7, 2 plus 2 to the power 7 minus 1. The fourth primitive data type is bool, which occupies 1 byte in the memory. When we are dealing with the bool, we have nothing like signed or unsigned, and here you might get a doubt that if we have to store only 0 or 1, which means true or false, what is the need to take 8 bits when the work can be done in 1 bit? The answer is we can't take a size of the variable less than 1 byte. All the remaining 7 bits are stuffed at random. The range for a bool is 0 or 1, which is true or false. There are no other values which we can store for a boolean variable. That's all for today. If you have enjoyed the video, drop a comment. Don't forget to hit like, share and subscribe to Autodidact, and click on the bell icon to be notified on all updates from Autodidact.